Hello everyone, welcome to the first lecture on the topic of functions. You might have seen many textbooks with that title of functions or advanced functions, or even many courses have this title. So the first thing we want to find out is what is a function to begin with? What is this so-called function that everybody talks about? By definition, a function is nothing but a rule, a simple rule. That's what it is. What kind of rule? A rule that gives a single output number for every valid input number. So that's what a function is. You can think of function as a machine, just like machines or different machinery in factories. There are huge machines in giant factories in big halls, and these machines have an input and they have an output. The input is like aluminum sheet metal, and then when you feed the machine with these um, aluminum sheet metals, the output is like one of those rectangular ducts that is made by the machine for the purpose of using in air conditioning systems of buildings. So there's an input and there's an output. The car you drive, the input is the gas you put in the car, the output is the motion that you get. So a machine, a function is just like a machine. So I put this function machine. But the thing is that this function must have a rule, and the rule is decided by you. You decide what the rule is. We have an input. Input is not gas in this case, and it's not aluminum sheet metal because we're dealing with like mathematical functions here. So the input output are all numbers basically. But the definition of the rule is to be decided by you. Let's say we are saying that an input number is doubled and then increased by 10. So if the input number, I have to use a letter for that. So if the input number is like, let's say x, okay, then I double that, okay, so that's 2x, and I increase it by 10, and that is the output number. But the output number, I have to choose a letter to show that. So I'm going to use letter y. You don't mind. So I'm going to say y equals 2x plus 10, and that becomes the rule that you and I collectively, define. We can define this rule to be squaring the input number, or we can say double the square of the input number, decrease it by 1, or we can say divide the input number by 4. Any kind of rule we can define. So here we are defining this rule here, this function. And x is the input number, or it represents the input number. For example, the input number could be anything you can think of. Let's say it can be 1, all right? So input could be 1. But if the input number is 1, then double 1 plus 10 is going to be 12. So the output number is going to be 12. If the input number is like 0, the output would be 10, of course. And if the input number is like a fraction, let's say 1/2, if you double it, it's 1 plus 10, it's 11. So for every input number, we do have an output number. I can just write something large, 1,000, for example. So it's going to be 2 times 1,000, that's 2,010. So 2,010 would be the output number. So a function is a rule that gives a single output number. When I said the output number is 12, I was not joking. I didn't say that it can be 12, but then on Mondays it's 13, on Tuesdays it could be 14, or sometimes it could be like 55. We never said that. We said that if x is 1, y is 12, period. That's what we said. So that's the meaning of single output number. It means that you can't change that. It's not like you decide. If x is 1, then y has a single output number. So it's a single number that is 12. It can't be 13. And then it says for every valid input number. Valid? What does that mean? Well, isn't 1 valid? Of course it's 1 valid. 0, 1/2, 1,000, fractions. How about negative numbers? So can we say negative 4 times 2 is negative 8 plus 2 plus 10 is 2. So that will be the output number. So can we have negative integers, positive integers, fractions, big numbers, small numbers, decimals, whatever. Sure, you can have an input number as long as it's a valid input number. Valid. So in this case, basically, I give you peace of mind. You can select any valid input number you want. Any real number you want, you can select. Okay? But sometimes, according to some rules that you define, probably, the input number may, I'm not saying always, may not be valid input number. Let me just on the spot give you an example, okay? So let's say you had decided that the rule is taking the input number and finding its reciprocal. Very simple, okay? You know reciprocal. Reciprocal of 4 is 1 over 4, so on and so forth. So the rule in that case would be 1 over x, okay? So if x is 1, it would be 1 over 1. The output number would be 1. If x is like 1/2, 1 over 1/2 would be 2. So the output number would be 2. So 1 and 1/2 are valid input numbers. But watch here. What if x is 0? What if the input number is 0? Can you divide 1 by 0? I doubt it. I know some of you say, oh, I can use my calculator. No, you can't use your calculator. Go ahead. So I know some of you are punching in the calculator right now and go, oh, let me see. No, you see what happened? You see what happened? You got the syntax error, right? It's right before your eyes. Look at your calculator. So this tells you that in mathematics, we can't divide numbers by 0. It is actually undefined. So if it is undefined, then you can't find any value for the output number. So that makes the input number of 0 invalid. So that's the meaning of this word in this definition when it says for every valid input number, because sometimes some of these input numbers are not valid. Like here, 0 is not valid, but 1 and 1/2 are valid. So we will talk about this extensively later on, but I just wanted to explain word by word what is the meaning of this so-called function. This definition, we understand, but word by word, what's going on. Okay, so we ended up with a whole bunch of numbers, input numbers, right? And to tell you the truth, the list goes on and on. I could have written like 2 million numbers here if I had the time, but I just wrote some numbers. Now, if you want, I can add more, But I had a whole bunch of input numbers, and here I had a whole bunch of output numbers. Okay, I put them in a bubble. All right. Now, what you have here is a set of numbers. Okay, set of input numbers. We have to give a name to this set. You can't just leave it as it is. In mathematics, that's a name. This name, the set of input numbers that you select actually, okay, independently you select. Nobody calculates anything. You can say, hey, you know what? I want to select x to be like 55 or 42, whatever. So you select, that is called domain, okay? So domain is the set. Domain is not type of fruit people eat, like an apple. Domain is a set of numbers. I know you have heard this word a lot in the past courses, but you always scratch your head, what is domain? Well, domain is nothing like, it's not a big deal. It's just the name of this set of input numbers. Everything, all of a sudden becomes clear. So same way that we had a name for the set of input numbers, we should have a name for the set of output numbers. So what name would you give this to this? Well, mathematicians decided the word range. So range and domain are two sets of numbers. Set of input numbers is called domain. Set of output numbers is called range. As simple as that. Okay, what about x and y? We are giving names to everything. So what should we call x? I know you're going to say, well, we can call it input number. But input number is not that professional, to tell you the truth. We call it, I would say we call it, let's give it a name. It's a variable, right? So we can call x to be a variable because it's a variable. You can change, you can pick anything you want. And then y is also variable, right? So y is a variable. In the same way that x is a variable, okay? But you agree with me if I call both of them variables. It's going to be very confusing. So I'm going to distinguish between them. I'm going to call this one, let's say, what name is good in your opinion to give this to this variable? What name? Okay, you got it. independent variable. That's a good suggestion. So independent variable. Okay, why? Because you selected these values independently, right? So I put down here, you select. But over there, that variable, is that independent variable? Can you select 13 instead of 12? You can't. So that value of 12 depends on the value of x, which was 1 before. So we're going to call this dependent variable. Okay, so y is dependent variable, x is independent variable. Okay, and right here I can tell you something, and that is the use of function notation. You know, instead of using letter y, which we call it dependent variable, you can show it with this notation, f of x. Okay, you must have learned about this in the past. So f of x is called function notation. So instead of writing y, we can show the function in the form of f and then open close brackets, put x inside. You read it as f of x. So f of x is the same as y. It's just called function notation. It's a way to show the dependent variable. Okay, so now that we learned what a function is to begin with, all right, we want to know how many ways can we represent a function? Well, one way is by an equation before your eyes, y equals to x plus 10. That's one way you can represent a function. But is that the only way? No, it's not the only way. You can use a graph. Actually, graphs are used a lot. In grade 9, years ago, you learned how to graph these kind of straight lines. We call them linear relations back then. So if the y-intercept is 10 and the slope is 2, so it would be a graph like this. So there you go. Y equals 2x plus 10 is the graph of this function we just used as our example. Okay, so you can represent the function using a graph. It's a visual way of studying a function, or you can use an equation. Both of these used a lot in mathematics. Mapping diagram is just another way you can represent a function. For example, you draw two bubbles. It's like a cool diagram, and you put down all your input numbers in the first bubble, okay, and your output numbers, you write them in the second bubble, all right. And then we say that 1 is mapped onto 12, 0 is mapped onto 10, 1/2 is mapped onto 11, and so on and so forth, okay. And this becomes like a diagram, which we call it mapping diagram, okay. -4 is mapped onto 2 according to the function f, whose definition is 2x plus 1, okay. A set of ordered pairs is another way of representing a function. So you can write this function in the form of a set of ordered pairs. For example, you can say 1, 12. So that means that x coordinate is 1, y coordinate is 12, and this is called an ordered pair. And because it's a set of ordered pairs, we use brace brackets to show that. So next one would be like 0, which was mapped onto 10. Then we have 1/2, 11. Then we have 1,000, 2010. Then we have -4, 2, and we close brace brackets. So what is this? It's a set. How do I know? Look at the brace brackets, open, close. What do you have inside the brace brackets? What do you have in this set? We have a whole bunch of ordered pairs. Of course, you know that. You could have selected any number. This is just an example, okay? Don't criticize me saying, oh, Mr. Such and such says that there's only 5 input numbers. No, I didn't say that. There's like millions and millions of input numbers here. This is just an example, okay? You don't expect me to sit down and write 5 million like ordered pairs. So this is a set of ordered pairs that you can use to represent a function. Table of values is another one. So you can construct a table of values, x and y. You can go like 1, 0, 1/2, 1,000, whatever input number you have, and then you write your output numbers, 2010 and 2. So table of values is another way of representing a function. And finally, you can use English words. Okay, for example, you can say double the input number increased by 10 to obtain the output number. So what is this? This is an English statement. So I used only words to describe the function. How many ways are there? There's 6 different ways that you can represent a function. An equation, used a lot. Graph, used a lot. Mapping diagram, not that much. Set of ordered pairs, sometimes. Table of values, used a lot. And using English words, rarely used. Okay, but these are the 6 ways that you can represent a function. And another thing I just have to mention to you is that when you have the graph of a function, okay, let's say you have a graph like this, okay, this is like a sort of parabola, which is like horizontal, okay. If you have an x value here, okay, this x value could have one value at the top and one value at the bottom. In other words, for one x, we have two y's. And this is in contradiction with the definition of a function, because we said that a function is a rule that gives a single output number. Let's say a single point with a single y coordinate, not 2 different points with 2 different y coordinates, obviously. So if you have a graph like this, by looking at it, if you draw a vertical line, okay, you can tell that this is not representing a function. And this test is called the vertical line test. So vertical line test states that if you have any kind of graph of a function and you draw a vertical line, and that vertical line crosses the graph at more than 1 point, 2 points, 10 points, whatever, then that graph does not belong to a function, it belongs to a relation. So here, this line is actually a function, because wherever you draw the vertical line, it is going to intersect the graph at only one single point, which means that we have a single output number for any valid input number that you select. Okay, so vertical line test, just wanted to mention that. Okay, we're going to continue in the next lecture. Thank you.